Hi everyone, I'm Brock. So today I want to review another open source AI project. And the first step is that we go to GitHub and search for the keyword AI. We already go through AltGPT and N88. The third one, ranked by starting, is called Stable Diffusion Web UI. So this is a homepage on GitHub. I download the whole repository. So you can see this is the source code, and this is readme.md. Okay, and based on the previous idea, I think that why playtest no matter a commercial AI product or open source AI project. The first key is not to know, the background knowledge. I think the key is to have some hands-on experience. And I find that there's no official link here. So what I did is I just directly search for state diffusion. This is a sponsored results. Let's skip it. So the first result is called Stable Diffusion Online. So I went to this website and ask AI to, when it generate a report, I ask it to tell me how to test stable diffusion. So this is domain name stablediffusionweb.com. Okay, so let's start it. Of course, as I mentioned, of course I can just go to this website and test it by myself. It's totally fine, but I think that have a guided, step-by-step guidance will make me more focused and targeted. So let's say open the browser, 10 credits every day, huh? Free plan. Okay. So this is a interface overview, prompt, and a model. Okay, base plus pro neutral, style, auto design, so on and so forth. Well, I prefer animation. And the aspect ratio, 16 versus 9. Upload a reference picture. It is contenting. Okay, maybe 1. Some advanced control, guidance scale, remove watermark. Okay, this is generate. It doesn't actually, okay. So firstly, test to image. Enter a prompt. Select model, choose style, set aspect ratio, send them an image, click generate or draw. Okay, it's already give a prompt, let's use it. Well, actually, I still want to try to use a whole story, a very long prompt to generate, let's say. I will use Harry Potter. So this is some parts of first chapter of Harry Potter. Okay, and I put everything inside it. I choose model, animation, aspect ratio, content. Let's generate. So every generation costs 1 credits. Okay. Interesting. Let me download it first. Surprisingly, it's actually be able to understand such a non-prompt and give me I should say it gets the key elements of the 3 characters, and it also provided the text, kind of like a comic book or a storybook. I think it makes me think about the Gemini storybook. I think it's pretty nice. Okay. Okay. Okay, second one is generation, image to image. Image to image. Oh, okay, I have 20 credits. Okay, so, okay. Yeah, I must subscribe to get more credits. That's fine. Image to image. So, okay. Upload a reference image. Okay, I will just upload my profile image. Oh. Drag and drop here. Hey, so you see there are some bugs. I should be able to drag a picture and drop it here, but you see, what happened is actually yeah. Let me try it again. About this time? No, it still doesn't work. Okay, so okay, so I upload the picture through select a file and okay. Actually, let me try another thing. So what I want to do is what I want to do is change the facial expression and the gesture of a let me find a template. Actually, the animations keeps play here. I actually don't like it because it's pretty disturbing. Okay, when I click it, it stops. That's good. Yeah, that's good. Because if I don't touch it, it will keep scrolling back and forth. It's actually caused a lot of distraction because humans' eyes are very sensitive to dynamic movement. So custom profile. So for example, I have two character portrait, and I want to change the gesture or facial expression of the person. So let's see whether we can do that. Oh, again, it's very annoying, So from a normal, for first time user, I think that the user experience is actually not so good. Okay, so you see, I upload the calculator avatar here. So I can give a prompt. So my goal is that change this character facial expression to, let's say, happy but shy. Change this character's dressing to, how to say, interesting. Google Translate get much smarter. It's not only give a direct translation, but it also, gives some, extra demonstration here, like traditional Chinese bride attire. I think that behind this is powered by Gemini. So it's pretty cool. Except facial expression and dressing. Don't change anything else for these characters. Okay, that's it. So the basic idea is I want to use it to change characters' facial expression and ensure consistency, so that the generated character should look like should be the same person with the input character. Right? I think that my prompt already be very very clear here. So base model, style. Okay, so here I just auto. And the ratio, yeah, so I think that the ratio is based on my input, so that's fine. 1 control. Okay, so don't change it, that's fine. And this image edit will cost 2 credits, let's see. Okay. Yeah, I think it's pretty nice, huh? So you see, this is the original one, and this is, the one. It has a watermark here, that's fine. But it changed her facial expression, changed her clothing, but keeps the same for her, even her hairstyle. Yeah, that's pretty nice. I remember that about 1 year ago, when I want to do this, the consistency is a big issue, but now it's not an issue anymore. So a lot of things we can do here. That's pretty cool. And also that we can generate a video or something like this. And transformation ideas, that's cool. And the in painting. How to do that in painting is here, AI photo effect. No, this is AI photo effect. AI Polaroid maker. What's Polaroid maker? Polaroid maker. So what's that? Polaroid.
Polaroid.
Okay. AI action figure generator. AI clothes changer. Oh, yeah. That's what I'm using actually just now, right? Change this person's clothes, but don't change anything else. AI builderness filter. Okay, interesting. AI pixel art generator for photos. AI celebrity selfie generator. I remember that about in 2017 maybe, former American President Obama went to Shanghai and have a speech. I heard that people, if they pay, maybe 100,000 Chinese yuan, then we'll get an opportunity to take a photo with Obama. But now, there's no need to pay such a sum of money to do that, right? AI can do it pretty well. Yeah, so I think that's all the, okay. Yeah, AI hug yourself. It's pretty interesting, very natural. And AI age filter. This action is a very cool application. That can change, Hey, here's a Chinese. What's wrong? Why it shows some Chinese here? Well, whatever. So this is in painting. Where's in painting? I didn't see where's in painting. Expand image. Okay. Upscale. Background remover. Setting. No, I didn't see where it's in painting. No. Out painting. Yeah, I think this is the extend crop fine tuning with. Oh, yeah. Oh, I got you. Oh, yeah. So this is, I guess this is the so-called. Okay. Expand the image. So maybe I can try it again. So maybe this one. Right. I want to extend the other parts. So adjust the frame size and it will automatically fill the empty space. So I think this is out painting. 2 credits. Let's just try it. Pretty nice, huh? Very, very well. I should say it's fine. I guess most humans won't distinguish the difference. And style selection and prompt database. Okay. Negative prompts. Okay, not include. That's interesting. State value. Okay, so same prompt, same value is same image. That's good. AI portrait. AI close changer. And some prompt tips. Be specific. Actually, we can use ChatGPT or some other tools to generate a good prompt before we ask the editor to generate an image. That's also something I think I can utilize in my visual novel generator. Use quality modifier. Specific art style. Include lighting details. Add composition keywords. Best workflow. Start. Define concept. Write base prompt. Add quality modifiers. Set negative prompts. Choose style. Generate first batch. Okay. Okay. Yeah, I think that the features for this website is pretty straightforward. And yeah, I think that's pretty much for the testing. And we can move on. It's much easier than than Google AI Studio. Well, because Google AI Studio provides more powerful and more features. So it takes longer time to test. But this one, it's straightforward. Okay, so let's have a look at the. Let's dive deep a little bit. So now we have a very straightforward understanding about what state diffusion can do. Then the next question is how state diffusion achieve those features. So state diffusion web UI, commonly called A1111 or automatic 1111, is a browser-based graphic interface for interacting with state diffusion, one of the most powerful open source image generation AI models. Think of it as Photoshop powered by AI. But instead of manually editing images, you describe what you want in words, and the AI creates it for you. Good. So first one, text to image. Yeah, I think this is very straightforward. The process is more interesting. So user will enter prompt to web UI, and web UI will convert text to embeddings to the clip encoder. Clip. In my previous videos, when I went through the open source projects in Hugging Face, actually I go through a clip. And the clip encoder will send a conditional signal to unite denoiser. What's unite? So we start from random noise. And what's this? It's overlap here. Denoiser, I guess. Gradually remove noise, then send a latent image to VAE decoder. What's VAE? And then decode to find image to web UI, and the web UI will display result to the user. Second feature is image to image. Also straightforward. And here is a parameter, denoising strength. The smaller the denoise, the manual change it is. Okay. In painting lets you select a specific area of an image, use a brush to create a mask, and regenerate only that area while keeping the rest unchanged. So what happened is input is original image, mask area. But actually, I didn't see this feature on this website, huh? I didn't see it, so yeah, not sure. Yeah, not sure. I didn't see. No. Didn't see that. And process is encode non-masked, generate mask area, blend seamlessness. Output is final image. From the attention system, This feature lets you control how much the AI focuses on different parts of your prompt. Aha. Interesting. It doesn't tell me. Well, okay. I don't know. I don't know whether state diffusion, this thing, supports such attention syntax. But I think that this syntax is very helpful because when we have a very long prompt, what should be focused on, what should be less important, we must have a way to tell AI, right? That makes a lot of sense. Negative prompts. Negative prompts like AI, what not to include in the image. Right, makes sense. This is critical for avoiding common generation artifacts. Makes sense, makes sense. Low rank adaptation, what's that? LoRa. LoRa is a technique for adding new styles or characters to the base model without retraining the entire model. That's fine-tuning, huh? It's like teaching the AI new skills efficiently. Okay. I think this is fine-tuning, huh? Upscaling and enhancement. The web UI includes several neural network-based upscalers that can increase image resolution while adding realistic details. Okay, so the upscaler at the end, under the hood actually needs some different kinds of neural network. Okay. Clip interrogator. This feature does the reverse of text to image. You give an image, and it generates a text prompt that could recreate similar image. Okay, so I guess the open source projects actually provide more feature than the web page, I think, or technologies. Okay, so for layer, front layer is Gradio Web UI, JavaScript, CSS. Backend layer is Fast API server, Python processing. Third layer is machine learning layer, include PyTorch framework, state diffusion model, clip text encoder, VAE encoder decoder. I forget the full name for clip and VAE again. Fourth layer, hardware layer, CUDA, GPU, CPU fallback. Okay. Latent diffusion model. LDM, what's this? Latent diffusion model is a core technology behind state diffusion. Instead of working directly with full resolution images, which would require enormous computing power, it works in a compressed latent space. Imagine you are an architecture designing a skyscraper. You could work with full-scale models, but that would require a wall house. Instead, you work with scaled-down blueprints. The latent space is like working with these compressed blueprints. You can do all the design work efficiently, and only at the end do you build the full-scale version? Okay. So here's some compression ratio. Okay. Diffusion process. So diffusion is a two-phase process. Forward diffusion. Gradually add noise to an image until it becomes pure random noise. Second part is reverse diffusion. Learn to reverse this process. Start from noise and gradually remove it to create an image. Oh, okay. Think of creating a marble sculpture. Forward diffusion is like watching someone take a finished statue and gradually cover it with layers of dust until you can't see the statue anymore. Reverse diffusion is like carefully remove the dust, layer by layer, and reveal the statue, except the AI learned to image what statue should be there based on your description. Well, I think that the process or the analogy is straightforward. I'm still not quite sure how do these two things can help AI learn things. Wow. Well. Okay, so for forward diffusion, it's clear image plus noise, more noise to pure noise, training. And the reverse diffusion is random noise, less noise, reduce more noise, generate image. It's still like a black box for me. I'll be right back. Give me 1 minute. Okay, sorry, I'm back. So let's move on. Mathematic foundation, noise schedule. Alpha sub t equals 1 minus beta sub t. Okay. VAE. Variational autoencoder. Variational autoencoder. Variational autoencoder. So a VAE is responsible for compressing images to latent space and to compressing them back. Think of VAE as a translator between two languages. Encoder is translate high-resolution image language into compact latent language. Decoder translates latent language back to image language. The Unite, it's a diffusion model, only speaks latent language. So VAE is essential for communication with human understandable image language. Okay, that's fine. So the pearl size is 512 dimension times 512 dimension image. Go into encoder, becomes 64 times 64 times 4 latent, and the unite processing, and then modified latent decoder get a 512 dimension times 512 dimension output. Flip is contrastive language image pre-training. Contrastive language image pre-training. So Clip is the brain that understands your text prompts. It will train on 400 million image text files from internet, learning to collect visual concepts with your textual description. Imagine a librarian who has seen millions of books and their covers. When you describe a book, a fantasy novel with a dragon on the cover, the librarian can immediately think of what that book should look like. Clip is this librarian. It bridges the gap between words and images. So the Clip architecture can be divided into paths. Text path is text input, tokenizer, text transformer, text embedding. And image path is image input, hash embedding, vision transformer, image embedding. Then do a similarity matching. Okay. Token limits. Standard Clip has a 77 token limit, approximately 60 to 70 words English. The Web UI removes this limitation, allowing unlimited prompt length. Unite architecture. Unite is a neural network that actually does the denoising, learning to remove noise from images. It's called Unite because its architecture looks like the letter U. If the diffusion process is about revealing a statue from dust, Unite is a sculpture's hand that actually removes each layer. It knows exactly how much to remove and well, guided by the text description from Clip. Why this looks like you? Where is the you? Encode path. Downsampling. Decoding path. Upsampling. Well, don't understand it very well. Cross-attention mechanism. This is how the Unite listens to your text prompt while generating the image. At each step, it asks, what should I generate here based on the text? The formulation is attention of QKV equals softmax. Oh, I forgot what's softmax again. It's dual normalization equals softmax of Q times K transpose divided by square root. But where's the T? Oh, K transpose. This means K transpose divided by square root of D sub K or dk times V. Okay. Sampling methods. Samplers are different algorithms for the denoising process. Each has trade-off between speed, quality, and style. Think of getting from point A noise to point B, final image like traveling. Euler, like driving straight, fast and direct, but match means scenic routes. DPM++, like in GPS with traffic patterns, traffic updates, efficient and smart. DDIM, like a train, predictable and reproducible, which means same seed will have generate the same result. Ancestral samplers plus A, like hacking with randomly routes more variable results. Okay. CFG scale, classifier free guidance. CFG scale control how strongly an AI follow your prompt. Higher value means stricter adherence to the prompt. But may reduce image quality. Imagine CFG 125 means here's a rough idea, use your creativity. CFG 729 means follow these guidelines, but add your touch. CFG 10 to 12, 15 means do exactly what I say, no deviation. Okay. Here's some AI or ML terminology. State diffusion. State diffusion is a deep learning text-to-image model that generates imagery by interactively denoising random noise condition on text embedding. State diffusion can generate a photorealistic image of a cat astronaut on the moon in under 10 seconds. VAE, variational autoencoder. It's a neural network architecture that learns to compress data into lower dimensional latent space and reconstruct it back. The VAE compressed 512 times 512 images into a 64 multiple 4 latent. It's a 48x the compression. CLIP, contrastive language image pre-training. It's a neural network trained on 400 million image text pile to understand the relationship between imagery and their textual expression. CLIP converts your prompt, a beautiful sunset of mountains, into a 768-dimensional vector that guides image generation. Unite U network, named after its U-shaped architecture. A convolutional neural network, convolutional neural network architecture with encoder-decoder structure and skip connections, used for image segmentation and generation. The unit in Stable Diffusion has about 860 million parameters and performs actual denoising at each step. Low-rank adaptation. A parameter-efficient fine-tuning techniques that train small adapter matrices instead of modifying the full model. A NORA file is typically 10 to 200 megabytes compared to the 4 GB base model, yet can dramatically change the output style. Latent space is a compressed, low-dimensional representation of data where similar items are close together. In Stable Diffusion's latent space, all cat images cluster together separate from dog images. Embedding, a dense vector representation of data in a continuous vector space. So what cat might be represented as a 768 dimension embedding vectors like checkpoint. A saved state of neural network's parameters at a specific point during or after training. The SDV 1.5 checkpoint is a 4 gigabytes file containing all 860 million plus parameters of the trained model. Inference. The process of using a trained model to generate prediction or outputs on new data. During inference, Stable Diffusion takes about 2 to 10 seconds to generate one image on modern GPU. Tokenization. The process of breaking text into smaller units that can be processed by a model. The sentence, a cute cat, tokenization to a cute cat, which is 3 tokens. But photographer might be photo, graph, or 3 tokens. Okay. Classifier-free guidance is a technique that improves text-to-image generation by combining conditional and unconditional predictions. With CFG scale is equals 7, the model generates output is unconditional plus 7 times conditional minus unconditional. Denoising. The process of removing noise from data in diffusion models. It relatively refines random noise into a coherent image. Diffusion typically uses 20 to 50 denoising steps, each step removing a portion of the noise. SDXL, State Diffusion XL. An enhanced version of State Diffusion with larger model size, better quality, and native 1020 times 1020 resolution support. SDXL have a 3.5 billion parameters compared to SD 1.5's 860 million parameters, about 4 times larger. Okay, system architecture. 4 layers. Layer 1, user interface layer, web browser, radio components, JavaScript, CSS. Layer 2, server layer, fast API background, backend, radio server, API in endpoints. Layer 3, processing layer, processing pipeline, script system, extension manager. Layer 4, machine learning layer, PyTorch runtime, model manager, sampler engine. Layer 5, models, clip text encoder, unit denoiser, VAE coder, module structure, core modules. Okay, 4. Module 1, core module, main entry point, launcher, global state. Module 2, UI modules, main UI, UI components, REST API. Module 3, generation modules, image processing, text to image, image to image. Module 4, model modules, model loading, samplers, VE management. Okay, text generation, image generation pipeline, text to image pipeline. User enter prompt and settings. To Web UI. Web UI will create a state diffusion processing, text to image. Send to processing. Processing will encode prompts to embeddings to send to clip. Clip will return text conditioning. And processing will predict noise to remove to unite. Unite will return noise prediction. And processor will apply sample steps. Then processor will decode latent to image through VAE encoder. And VAE will return final image to processing to Web UI. And Web UI will display results to user. An extended system architecture. 3 layer. Layer 1, extension tabs, building extensions, user extensions. Layer 2, building, LoRa network, Spring IR upscaler, LDSR upscaler, School Night denoiser, Hyper tail. Layer 3, callback system, on UI tabs, on model noded, on image saved, on CFG denoiser. Data flow diagram. If I don't ask AI to generate those architecture and images and directly read the source code, I don't know how many time I need to spend. And I'm really admire those people who learn the architecture by read through the source code. They are very amazing. Okay, so 3 parts. Part 1 is input data include reference image prompt, negative prompt setting. Part 2, processing include text encoder, iterative denoising, image decoding, noise generation. Part 3, output data, generated image, metadata, generation information. Okay, model loading architecture, checkpoint info class. Oh, this is okay, so the checkpoint inform class manage model metadata, including file paths and stiff tensor support. Okay, fair enough. API architecture. I guess because I provide the source code, so when AI generates the architecture, it actually can generate it in a double dip a little bit and generate more detailed, much fine-grained details, architectures. Okay. So API, 3 parts: API endpoints. Part 2, model API. Part 3, system API. Okay, and fast API router, processing pipeline. Memory management. VRAM optimization strategies. 2 parts. Memory modes: normal mode, medium, no. Okay. And some terminology. Feed-forward network. A neural network where information flows in one direction from input to output without cycles. In transformer, each attention layer is followed by a feed forward with 2 linear layers and the GLU activation. What's GLU? Attention mechanism. A technique allows models to focus on relative parts of input when generating output. When generating an image of a red car, attention helps the model focus on red when coloring the car. Cross attention. An attention mechanism where queries came from one sequence and keys values from another. In stable diffusion, cross attention connects image features to text features. Self-attention. An attention mechanism where a sequence attends to itself, finding relationships between different positions. Self-attention in the unit helps different parts of the image maintain consistency with each other. Transformer, a neural network architecture based entirely on attention mechanisms without recurrence or convolution. Clip uses a transformer with 12 layers and 12 attention heads to encode text into embedding. Convolution, a mathematical operation that slides a filter over input data to detect features. The unit uses 3 times 3 convolutions to process the latent image, detecting edges, textures, and patterns. Skip connection, a connection that allows information to bypass one or more layers, helping gradient flow. Units skip connections preserve fine details by connecting encoded layers directing to decoded layers. Batch normalization, a technique that normalizes the layer inputs to have 0 mean and unit variance across the batch. Batch norm helps the norm train faster by keeping activation value in a healthy range. Gradient descent, an optimization algorithm that interactively adjusts parameters in the direction that reduce loss. During training, gradient descent updates unit weights to make a bad noise prediction. Softmax, a function that converts a vector of numbers into a probability distribution. Softmax in attention ensures attention weights sum to 1, representing relative importance. Well, I think this part is very, I should say, very detailed, very helpful for me to understand what's going on under the hood, right? Just now, we at very beginning, we just play around and feel very impressed by what stable diffusion can do like this, but we actually don't know how the magic work. And this part, although I still don't understand it very well, but at least it gives me some sense, give me some bird view on a architecture level. Yeah, very helpful for me to understand this open source project. And the other part is more like a commercial focused, and we can just quickly go through it. Okay, so published on August 2022, only 3 years. So within 3 years, so many things can happen. So many things. Yeah, it's about 143,000 stars. That's a lot. Okay, so although it's not an academic paper, but it's often cited by research papers. Okay, and used in a lot of commercial workflow. So State Diffusion Web UI's creator, known by a pseudonym name, Automatic 11111. Okay, choose to remain relatively anonymous. Okay. Development philosophy, accessibility first, performance focused, community driven, practical over theoretical. This sounds like a Chinese. Sometimes I feel pity that myself is not a very, not a big, technology fan, which get crazy about coding. I'm not. Oh, okay. So Web UI itself is not a company that has no market value. It's a pure open source project without commercial funding. However, the underlying stable diffusion technology comes from Stability AI. Okay. Competitors. Closed source competitors, Midjourney. DALL-E 3. Oh, it pronounced as DALL-E 3. That's interesting. Adobe Firefly. Open source competitors. Comfy UI. I think that I saw Comfy UI on the list. You see here? It's around 96,000. No hurries, we will go to this one very soon. And actually, I'm very excited to go through the list one by one because each open source projects helped me learn a lot. I really hope that I began interested to do what I'm doing now when I was first year in college. That's very interesting. We change a lot, right? As time went by, our interests, our mindset changes a lot. Focus, invoke AI, SWOT analysis. Okay, good. Third part 3, what's this? Some core insights. The power of community-driven development. Speed to market that matters. Extensibility as competitive mode. The good enough paradox. Latent space is revolutionary. Attention mechanism democratized control. Memory optimization creates accessibility. Free plus open source isn't equal no value. The anonymous developer advantages. Democratization of art, AI art. Okay, some suggestion for me. Lessons to avoid. What not to learn. China and US technology analysis. Okay. So for foundation model, China is following, American leading, China following, open source, American strong, China growing. Commercial apps, American global reach, China domestic focused. Regulation, American evolving, US evolving, China stricter. Talent, US global recruitment, China domestic and returnees. Okay, pretty good. Part 4. Okay, so position recommendation. Forward deployed engineer. Let me see. I already plan to apply for Anthropic, so I will just skip this one. Leonardo AI. Yeah, let's see. Maybe I can give it a try. Solutions engineer. No, it doesn't have solutions engineer role. Nope. And most of them are based in either Australia or New Zealand. So yeah. Ron Rod, customer success engineer. No, no, it doesn't have such a role. Customer success engineer. No, it doesn't. It's it keeps giving some fake positions which doesn't exist at all. The hallucination is so obvious. Skill AI. Yeah, I don't apply for any skill AI position. So let's see. Okay, solution engineer. Something interesting? Let's see whether it has some sponsorship limitation. Okay, it doesn't mention. That's good. Yeah. Yes. Okay. Lambda Labs. Developer advocate. Do we have such developer? No, it doesn't have developer advocates. No. How about solutions engineer? Let me see. Uh, it requires 8 years work experience. I don't have that, but but maybe still give it a try. Conjuring face. Yeah. Technical account manager. Do they have such position? I'm not sure. Okay. It doesn't have any jobs. Okay, it's only 4 positions. Yeah, no. Oh, it's only look for machine learning engineers, no replicate custom engineer. We don't have any open rows. Pooling. Let's say the reals. Oh, there's no. Okay. So solutions engineer. I think that most of the positions are, for senior roles. So Cohere. Do we have solutions engineer? Solution is in Japan. No. Yeah, Japan, London. No. I want to find one more. Which one? Agentic platform. Okay, forward. North America. Okay, forward deployed engineering. It has so many such roles. North America, include America. Toronto, Canada. Okay, all this in. No, I don't know. Can you? It's very ridiculous. You see, the category nation and the city is in the same level. That's very ridiculous, right? Okay, so this is in Japan, Korea. Okay, no, America. No. Okay, here. Okay, here I find something in New York or San Francisco. Let's see. Okay, that sounds interesting because it doesn't mention any limitation for visa. So here, yeah, I think that I already collect three positions. It's good enough. Yeah. This part is very helpful. It's much better than I just search on LinkedIn or something randomly. It's more efficient. So the last part is, should I refactor my architecture? So basically, the conclusion is that Hongyi.ai should not fully refactor to mirror SD Web UI's architecture. However, should integrate SD Web UI as external service via its API. The two projects are severe different purpose. SD Web UI is a general purpose image generation tool, while Hongyi.ai is a specialized visual novel generator. Okay. Okay, so this is helpful, but for the sake of time, I want to go through it. Yeah, later. That's a lot for today, and thank you everyone. Bye.